March 14, 1953. Harold Weiss finished walking his back 40 and found his corn stand thin again. Third year in a row. The soil report said nitrogen deficiency. The extension agent recommended ammonium nitrate at 60 pounds per acre. Cost would run $412 for his 240 acres. Weiss had borrowed $3,000 the previous fall to buy a used Farmall M. He still owed $2,100. What brought his yields back was a planting schedule written on a piece of paper that weighed less than an ounce. A schedule that every agricultural college in the Midwest had called outdated by 1949. If you want to understand how American agriculture forgot something that worked better than what replaced it, hit subscribe now. This story involves numbers nobody wanted published. The system was called the Norfolk rotation. 4 fields, 4 crops, 4 years, wheat first year, turnips second, barley third, clover fourth, then back to wheat. The cycle had been documented in England in 1730 by Charles Townshend, a retired diplomat who spent his last 30 years breeding turnips on his Norfolk estate. By 1820, the system was standard practice across the wheat-growing regions of Britain. Average wheat yields in Norfolk went from 12 bushels per acre in 1700 to 28 bushels per acre by 1840. No outside fertilizer, no chemical intervention, just the rotation. The system crossed into American agriculture in the 1780s. Thomas Jefferson tested it at Monticello starting in 1794. His farm records from 1801 show wheat yields of 22 bushels per acre on rotated fields versus 14 bushels on continuously cropped ground. Same soil type, same seed stock. The difference was the clover year. Clover pulled nitrogen from the air and stored it in root nodules. When the clover was plowed under, that nitrogen became available to the next wheat crop. By 1890, the Norfolk rotation was recommended practice in every major agricultural textbook published in the United States. The USDA Yearbook of Agriculture for 1894 devoted 47 pages to rotation systems. The introduction stated, "No system of farming can be considered permanent which does not include a regular rotation of crops including a legume." The legume was always clover or alfalfa. The nitrogen cycle was understood. The results were documented. Then the numbers shifted. In 1909, Fritz Haber synthesized ammonia from atmospheric nitrogen using high pressure and an iron catalyst. By 1913, BASF was producing synthetic ammonia at industrial scale. The Haber-Bosch process converted natural gas and air into ammonia at a cost of 3 cents per pound of nitrogen. By 1920, that ammonia could be converted into ammonium nitrate and sold to farmers as fertilizer for 8 cents per pound of nitrogen. The economics were immediate. A farmer growing corn in Iowa in 1922 could apply 40 pounds of nitrogen per acre as ammonium nitrate for $3.20. The yield increase averaged 12 bushels per acre. At $1 per bushel, that was $12 of additional revenue for $3.20 of input cost. Net gain of $8.80 per acre. For a 200-acre farm, that was $1,760 of additional profit in a single season. The clover year and a Norfolk rotation added nitrogen, but it produced no grain crop. A farmer running a 4-year rotation only harvested grain from 3 of those years. The 4th year was investment. Continuous corn with synthetic nitrogen produced revenue every year. The immediate financial advantage was clear. By 1935, American farmers were applying 240,000 tons of synthetic nitrogen annually. By 1945, that number was 800,000 tons. The USDA began recommending continuous cropping with chemical fertilizer in official guidance documents. The 1943 USDA publication, Fertilizers and Crop Production, stated, "Modern fertilizers make it possible to grow the same crop year after year on the same land without loss of yield." Rotation was described as a traditional practice with historical value but no longer necessary given available technology. Agricultural colleges followed. The University of Illinois published a bulletin in 1947 titled Continuous Corn Production with Commercial Fertilizers. The abstract concluded, "Rotations including legumes are not required to maintain soil productivity when adequate commercial fertilizer is applied." Iowa State published similar guidance in 1948, Purdue in 1949. The message was uniform: rotation was old practice. Synthetic nitrogen was modern science. What the guidance did not include were the trial results that did not support the conclusion. Those results existed. They were published in academic journals with limited circulation. They were not included in extension bulletins sent to farmers. The first major data set came from the Morrow plots at the University of Illinois. The plots were established in 1876 as a permanent soil fertility experiment. 3 plots. Plot 1 grew continuous corn with no fertilizer. Plot 2 grew corn in a corn oats rotation. Plot 3 grew corn in a corn oats clover rotation. The plots had never been moved, same soil, same management, 73 years of continuous data by 1949. In 1949, the university split each plot. Half received synthetic nitrogen at 160 pounds per acre, half received nothing. The results were published in the Journal of Soil Science in December 1950. Author was Erasmus de Turck, head of the agronomy department. On the unfertilized halves, corn yields averaged 28 bushels per acre on the continuous corn plot, 41 bushels on the corn oats plot, and 63 bushels on the corn oats clover plot. That matched 70 years of previous data. Rotation with clover more than doubled yields compared to continuous corn. On the fertilized halves, the results diverged from expectation. Continuous corn with synthetic nitrogen yielded 89 bushels per acre. Corn oats with synthetic nitrogen yielded 97 bushels. Corn oats clover with synthetic nitrogen yielded 118 bushels per acre. The clover rotation still outperformed continuous corn by 29 bushels per acre, even when both received identical nitrogen fertilizer. De Turck noted the difference in his discussion section. He wrote, "The rotation effect persists under high fertility conditions and cannot be attributed solely to nitrogen supply." He did not speculate on cause. The paper was 11 pages long. It appeared in an academic journal with a subscription base of 840 researchers. It was not covered in extension publications. A second trial produced similar results. Rothamsted Experimental Station in England had been running continuous cropping trials since 1843. The broad bulk winter wheat experiment was the longest-running agricultural trial in the world. One plot had grown wheat every year since 1843 with no fertilizer. One plot had grown wheat every year with farmyard manure. One plot rotated wheat with fallow and clover. In 1951, Rothamsted added synthetic nitrogen to half of each plot. The results were published in the Journal of Agricultural Science in March 1953. The continuous wheat plot with synthetic nitrogen yielded 31 bushels per acre. The rotated plot with synthetic nitrogen yielded 44 bushels per acre. Same nitrogen input, 13 bushels per acre difference. The paper noted, the beneficial effects of rotation cannot be wholly explained by nutrient supply. The author was E. M. Crowther, head of the chemistry department. The Rothamsted paper circulated within academic soil science but did not reach extension communications. A summary appeared in the USDA Technical Bulletin series in August 1953, but that series had a circulation of 3,000 copies, mostly to university libraries. Harold Weiss did not read the Journal of Agricultural Science. He read Wallace's Farmer, which had a circulation of 280,000 across Iowa and surrounding states. Wallace's Farmer ran a feature article in April 1952 titled Rotate or Fertilize. The article quoted an Iowa State Extension agronomist named Peter Harkin. Harkin stated, "With modern fertilizers, rotation for soil fertility is unnecessary. Rotate only if you need the crop diversity for market reasons." Weiss had been farming 240 acres near Grundy Center, Iowa, since 1946. He grew continuous corn. He applied ammonium nitrate every spring at 60 pounds of nitrogen per acre. His yields in 1950 were 94 bushels per acre. In 1951, 87 bushels. In 1952, 81 bushels. Soil tests showed adequate nitrogen, phosphorus, and potassium. The county agent told him the dry August had caused the drop. Weiss knew 5 neighbors with the same soil type who had normal rainfall and still saw declining yields under continuous corn. In March 1953, Weiss drove to the Iowa State Extension Office in Marshalltown and asked to see trial data on continuous corn versus rotation. The agent gave him a bulletin from 1948. The bulletin showed that corn following clover yielded 12 bushels per acre more than continuous corn when both received the same fertilizer. The bulletin recommended rotation. Weiss asked why the 1952 article in Wallace's Farmer said rotation was unnecessary. The agent said the new guidance reflected updated research. Weiss asked to see that research. The agent did not have it. Weiss wrote to Iowa State directly. He received a reply from Kenneth Beeson, Associate Professor of Agronomy, dated April 3, 1953. Beeson enclosed a 3-page summary of rotation trials conducted at Iowa State between 1947 and 1952. The summary included data from 4 trial sites across central Iowa. All 4 sites showed the same pattern. Corn following clover outyielded continuous corn by an average of 14 bushels per acre when both received identical synthetic nitrogen. Beeson included a note. It read, "Our data consistently show a rotation advantage. I cannot explain why extension guidance does not reflect this. The difference is economically significant." Weiss calculated his own numbers. 14 bushels per acre on 240 acres was 3,360 bushels. At $1.30 per bushel, that was $4,368 of additional revenue. Running a clover year meant losing 1 year of corn revenue every 4 years. On 60 acres, that was a loss of approximately $5,400 at his current yields. But if the rotation brought his yields back to where they had been in 1950, the gain over 4 years more than offset the lost year. He decided to test it on a quarter of his farm. 60 acres went into clover in May 1953. The remaining 180 stayed in continuous corn with synthetic nitrogen. The clover stand came in thick. Weiss cut it once in July for hay, then let it grow through fall. He plowed it under in October. The soil turned dark and loose. He planted corn on those 60 acres in May 1954. The stand emerged even and grew fast. By August, the stalks were a foot taller than his continuous corn on identical soil 30 yards away. Harvest came in October. Weiss ran his picker through the rotated corn first. He weighed every load. The 60 acres yielded 107 bushels per acre. He moved to the continuous corn, same picker settings, same moisture conditions. Yield was 83 bushels per acre, 24 bushels difference. Weiss wrote the numbers in his farm ledger. He noted the date, October 18, 1954. He converted the rest of his farm to rotation that fall. The question Weiss could not answer was why the clover made a difference beyond nitrogen. The soil tests showed both fields had adequate nitrogen after synthetic fertilizer application. The yields showed the rotated field performed as if it had something the continuous field lacked. Weiss did not have laboratory equipment. He had observation. The answer came from research being conducted simultaneously at Purdue University. The researcher was Stanley Barber, an assistant professor of soil microbiology. Barber was not studying rotation. He was studying root diseases in continuous corn. Barber had noticed that continuous cornfields in Indiana were showing increased root rot even when soil fertility was maintained with synthetic fertilizer. He collected root samples from 30 fields in 1952. 20 fields were continuous corn, 10 were corn following clover or alfalfa. All 30 fields had received identical nitrogen fertilizer. Under microscopic examination, roots from continuous corn showed heavy infection with Fusarium and Pythium fungi. Roots from rotated corn showed minimal infection. Barber cultured the soil from both field types. Continuous corn soil had fungal populations averaging 42,000 colony-forming units per gram of soil. Rotated soil had 18,000. Barber published his findings in the journal Phytopathology in June 1955. The title was Effect of Crop Rotation on Root Disease Incidence in Corn. The core finding: rotation with legumes significantly reduces pathogenic fungal populations in soil independent of nitrogen fertility status. The mechanism was not the clover itself, it was the break in the disease cycle. Fusarium and Pythium were host-specific. They infected corn roots but could not infect clover. A year without corn meant a year without host availability. Fungal populations crashed. When corn returned, the disease pressure was minimal. Root systems stayed healthy. Healthy roots accessed nutrients more efficiently. Yields increased even when soil nutrient levels were identical. Barber did not recommend abandoning synthetic nitrogen. He recommended combining rotation with fertilizer. His conclusions stated, "Maximum yields require both adequate soil fertility and disease suppression through rotation. Neither practice alone produces optimal results." The Purdue paper circulated within plant pathology but did not reach agronomic extension. Barber presented the findings at the American Phytopathological Society meeting in August 1955. Attendance was 312 researchers, no extension agents, no farmers. The information spread slowly through informal networks. A county agent in Tippecanoe County, Indiana, read the Barber paper and mentioned it in a local Farm Bureau meeting in November 1955. A farmer named Robert Kessler was in attendance. Kessler had been fighting root rot in continuous corn for 3 years. He planted 60 acres of alfalfa in spring 1956, plowed it under in fall 1957, and planted corn in 1958. His yields went from 76 bushels per acre in 1955 to 114 bushels in 1958. He told 8 neighbors, 6 of them tested rotation in 1959. The results were consistent. Corn following a legume year out-yielded continuous corn by 15 to 30 bushels per acre depending on disease pressure, even when synthetic nitrogen was applied to both. The difference was not nitrogen, it was root health. By 1960, the data was clear enough that it could no longer be ignored in extension communications. Iowa State published a revised bulletin in March 1961, titled Crop Rotation and Soil Productivity. The bulletin included 4 years of trial data showing rotation advantages. The introduction stated, "Recent research indicates that rotation benefits extend beyond nitrogen supply and include disease suppression and improved soil structure." The bulletin was written by Wilbur Lang, an extension agronomist who had been at Iowa State since 1947. Lang had written the 1948 bulletin recommending rotation. He had watched that recommendation get reversed in 1952. He had seen the reversal contradict his own trial data. The 1961 bulletin was a return to the original guidance, supported by the pathology research that explained why rotation worked. Lang included a cost comparison table. Continuous corn with synthetic nitrogen at recommended rates cost $11.40 per acre in fertilizer. Average yield in Iowa trials was 87 bushels per acre. Corn in rotation following clover required the same fertilizer cost but yielded 103 bushels per acre. The clover year cost $18 per acre in seed and planting, but produced hay valued at $32 per acre. Net advantage over 4 years was $168 per 240 acres annually. The economic case supported rotation. The biological case supported rotation. The long-term trial data supported rotation. The guidance that had called rotation unnecessary in 1952 was quietly revised without acknowledgement that the previous guidance had been incorrect. No formal retraction was issued. No explanation was published for why extension communications had diverged from trial data between 1948 and 1961. The 1961 bulletin simply presented rotation as recommended practice, as if the previous decade of contrary guidance had not occurred. The shift back toward rotation was slow. Synthetic nitrogen use continued to increase. By 1970, American farmers were applying 7 million tons of nitrogen annually. The majority went on to continuous corn and continuous wheat. Rotation acreage declined from 42% of corn acres in 1950 to 28% in 1970. But within that decline, a subset of farmers maintained rotations and documented results. The data accumulated in farm records, in county agent files, and in long-term university trials that continued regardless of extension messaging. The Morrow plots at Illinois continued. By 1975, the corn oats clover rotation with synthetic nitrogen was out-yielding continuous corn with synthetic nitrogen by an average of 31 bushels per acre. 100 years of continuous data. The pattern had not changed. Roth-Amstad continued. By 1980, the broad-bulk rotation plots were out-yielding continuous wheat by 18 bushels per acre when both received identical fertilizer. 137 years of data. Same result. Independent verification came from outside the academic system. The Rodale Institute in Pennsylvania established a side-by-side trial in 1981 comparing continuous corn with synthetic inputs versus corn in rotation with legumes and compost. The trial was designed to run for 40 years. Results were published annually. By 1990, after 9 years of data, the rotated corn was yielding 98 bushels per acre versus 91 for continuous corn with synthetic nitrogen. By 2000, the gap had widened to 107 versus 86. The continuous corn yields were declining. The rotated corn yields were stable. The Rodale trial added economic data that university trials rarely tracked. Total input costs for continuous corn averaged $192 per acre including seed, fertilizer, and pesticides. Input costs for rotated corn averaged $87 per acre. At $3 per bushel, the rotated corn returned $321 per acre versus $258 for continuous corn. Net advantage of $63 per acre. The trial results were published in peer-reviewed journals. A summary appeared in the American Journal of Alternative Agriculture in 2002. The conclusion stated, long-term data demonstrates that rotations including legumes maintain yields and reduce input costs compared to continuous cropping with synthetic fertilizers. The paper cited 15 separate long-term trials from 6 countries. All showed the same pattern. Rotation with legumes produced equal or higher yields than continuous cropping while requiring lower fertilizer inputs. The nitrogen benefit was secondary. The primary benefit was disease suppression and soil structure maintenance. By 2010, the agronomic consensus had shifted back toward rotation. The USDA Natural Resources Conservation Service published a technical note in January 2011 titled Crop Rotation for Soil Health. The note stated, "Diverse crop rotations are essential for maintaining long-term soil productivity. Synthetic fertilizers provide nutrients but do not address soil biology or disease cycles." The note recommended a minimum 3-year rotation including at least one legume. It cited 40 years of research. It did not mention that the same recommendation had been standard practice in 1940, abandoned in 1950, and was now being reintroduced as if newly discovered. The institutional memory had failed. The rotation systems that had built American agriculture in the 19th century had been discarded in the mid-20th century based on short-term economic analysis. The long-term costs of that decision had taken 30 years to become visible in declining yields and increasing input costs. The solution being recommended in 2011 was identical to the practice that had been called primitive in 1952. Modern precision agriculture uses the same rotation principles identified in the Norfolk system of 1730. Current USDA guidance recommends corn-soybean rotation as a minimum. Soybeans are legumes, they fix nitrogen, they break disease cycles. The rotation benefit is now quantified using soil microbial DNA sequencing and root pathogen load measurements, but the underlying mechanism is identical to what Charles Townshend observed in his turnip fields in 1730. The 4-year Norfolk rotation is still in use. Organic grain farms across the Midwest run variants of wheat clover corn oat cycles. The Rodale trial continues. As of 2023, 42 years of data show rotated corn outyielding continuous corn by an average of 22 bushels per acre with 60% lower input costs. Harold Weiss farmed his 240 acres near Grundy Center until 1987. He ran a corn oats clover rotation for 33 years. His yields averaged 108 bushels per acre on corn. His fertilizer cost averaged $62 per acre. He never returned to continuous corn. He died in 1991 at age 74. His son still farms the land using the same rotation. The piece of paper Weiss wrote his rotation schedule on in 1954 is in a file box in his son's machine shed. The paper is yellowed. The handwriting is in pencil. It lists 4 fields and 4 crops and the years each field would carry each crop. 60 acres clover, 60 acres wheat, 60 acres corn, 60 acres oats. Rotate each field through all 4 crops over 4 years, then repeat. The schedule weighs less than an ounce. It outperformed every modern alternative tested against it in independent trials spanning 283 years. If you have experience with rotation systems or long-term soil fertility management, leave a comment below. Tell us where you are farming and what rotation schedule you have found most effective. If this kind of agricultural history documentation matters to you, subscribe. There are more stories like this that need to be told before the people who lived them are gone.